Okay, last section of notes for this chapter, and then we are done. 11.8 is on, again, the binomial theorem like we did yesterday, and the first page of this notes sheet is we're just going to review from what we did from in 11.8 day 1, just so we wrap up any last minute questions or details, because we do need to know how to do this for this chapter, and this stuff is something that could come up on the MCA grad test. So example number 1 is to expand the binomial. So remember we talked about Pascal's triangle yesterday, and the first thing you need to know is what's the 7th row of Pascal's triangle for this one. So remember, this is something where you can just make a little triangle off to the side and figure out what the 7th row is going to be. So let's do that quick first, just so we have it written down, because we're going to need this for the first couple of them. If you have your notes from the day before that you can get out, you could do that as well. That's always something good to do. But we can do this quick enough. So remember, I'm just adding from the row before, looking for that 7th row. One more, 7, and I'll just rewrite this over here. So the numbers we're going to use for this one are 1, 7, 21, 35, 35, 21, 7, and 1. Okay, so there is our triangle, our coefficients that we're going to use. So let's expand this out. So my first coefficient's a 1. I'm going to start with my first part of my first variable, which is an a, and I'm going to raise that to my 7th power, because that's what I'm starting with. Second variable is a b. Now in this case it is a negative b because of that negative sign there. So I'm going to throw that negative b in there. Now if you want to just remember that your signs are going to alternate when you write out your answer, you could do that as well. Okay, and ignore the negative for now. Plus, my next coefficient is a 7. A to the 6th, because I'm going to begin to count down with my a's, but I'm going to count up with my b's. Plus 21, a to the 5th, negative b to the 2nd, plus 35, a to the 4th, negative b to the 3rd, plus 35, a to the 3rd, negative b to the 4th, plus 21, a to the 2nd, negative b to the 3rd. Oops, see? I do that sometimes where all of a sudden I'll start counting down when I'm supposed to be counting up on that b. There we go, 5 plus 7, a to the 1st, negative b to the 6th, one more coefficient left, a to the 0, negative b to the 7th. Okay, last step, we're going to clean this up. Now this is where in the past I've had troubles with. People will get this step, so they'll get partial credit, like on a test or a quiz for this section, but then they'll goof up and they can't clean it up very nicely. Remember, anything to the 0 power, wipe it out. You don't have to write it down. It's just a 1. When you multiply something else by 1, it's going to be whatever that something else is. Here we have 1 times a to the 7th. That's just an a to the 7th. Now because I have a negative here, my signs are going to start to, my signs are going to alternate. I'm going to start with a negative and I'm going to go positive, positive, and so on. Because remember, this is just like we have a negative b to the 1st, which is just negative b, and negative b times 7 is going to give us a negative 7b. So negative 7, and I have a to the 6th, and then b to the 1st. Again, you don't have to write that first power. It's assumed. Plus, because I'm going to alternate my signs, 21a to the 5th, b squared, minus 35, a to the 4th, b to the cube, plus 35, a to the 3rd, b to the 4th, minus 21, a squared, b to the 5th, plus 7a, b to the 6th, minus b to the 7th. Now remember, anything with an odd exponent is going to have a negative sign in front of it for the b. So if you take a look at your b's, even exponent has a positive sign in front of it. Odd, negative, positive, positive, odd, negative, even, positive. Okay, kind of another trick to remember in order to just double checking to make sure that these are right. Okay, let's take a look at one more and then we're going to go on to new stuff on the back side. So now in this one, I need my 5th tier of my triangle, which I'm just going to rewrite so I can see it on my screen as 1, 5, 10, 10, 5, 1. And I'm going to add in my variables. Now let's think of this as our a and this as our b. just like we did from the other one. So my first coefficient is a 1. My a is a 3m, so I'm going to take that 3m and I'm going to raise it to my nth power, which is a 5. This again is my n. Take my b, which happens to be actually a d, and raise it to the 0 power. Plus, no negatives to worry about on this one because I have a plus sign here, not a minus sign. Don't have to worry about switching any signs. 5. I have 3m to the 4th, d to the 1st, plus 10, 3m to the 3rd, d to the 2nd, plus 10, 3m to the 2nd, d to the 3rd, plus 5, 3m to the 1st, d to the 4th, plus 1, 3m to the 0, d to the 5th. Another thing that's cool that you can double check on these is all your exponents are going to add up to 5. So 3 and 2 make 5, 2 and 3 make 5, 1 and 4 makes 5, 0 and 5 makes 5. Okay? Last step, let's clean this up. d to the 0 is gone, 3m to the 5th. Now that means 3 is being raised to the 5th power and m is being raised to the 5th power. If you type in 3 to the 5th in your calculator, you're going to get 243 and m to the 5th plus, here I have 3 to the 4th, which is 3 times 3 is 9. 9 times 9 is going to be 81. So this 3 to the 4th right here is just 81. 81 times 5, so notice do the exponents first. 81 times 5 is going to give me 405. And I have m to the 4th, d to the 1st, plus 3 cubed is 27. 27 times 10 is going to give me 270. M to the 3rd, d squared, plus 3 squared gives me 9. 9 times 10 is 90. M squared, d to the 3rd, plus, here I have 3 to the 1st is just 3. 5 times 3 is 15. And then 1m and 4 d's. And last one, that's gone, d to the 5th. And there is that cleaned up version. So those are going to be the harder ones to clean up, and really basically it's just because you have numbers being raised to exponents versus just a variable being raised to the exponent. Next side. Mine looks a little bit goofy. And you do not need to write this down because this should already be typed in for you. So we're going to talk about this one. Reason I already typed it in is because it's a lot of variables to kind of remember on this one. So it says finding the kth term of the sequence. Basically, these questions are going to say, find the 7th term of this big, large sequence. For example, this one here. This could have said, find the 5th term of this sequence. So the 5th term would be 1, 2, 3, 4, 5. And this would be your answer. So could you do these ones on the back by using what we've already been doing and then just saying, oh, here's your 5th term, that's my answer? Yes, but you're doing a lot of extra work that you don't actually need to do. So what we're going to do is we're going to use this formula in order to figure out what that term specifically is. So because we're looking for the 7th term, that actually means that k equals 6 in our formula, which doesn't make sense at first until you read this. K0 is the first term. K1 is the second term. So if we're looking for the 7th term, then we're actually looking for when k is 6. And that's what we're going to use for these k's here in this formula. This number here tells us, again, just like it always has, what our n is. So here, n equals 11 for our formula. So let's go ahead and plug this in. So I'm starting off with x plus y to the 11th power. That's what they started me off at. And I'm going to plug these numbers in. My n is 11, so on top I have 11 factorial. I introduced you to the factorial sign yesterday. Over k, which is 6 factorial, times n minus k, so 11 minus 6, factorial sign on the outside. And then last step is our variables. A, in this case, is an x, to the n minus k, so 11 minus 6. And then b, which in this case is a y, to the k power, which is a 6. So all I did was plug in all of my numbers into this equation right here. Now I'm going to simplify. 11 factorial, remember, is like you have 11 times 10 times 9 times 8 times 7 times, I'm going to go dot 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 after that because I'm going to show you what's going to happen on the bottom. Well, maybe I won't. I'll show you that shortcut on the next one so then you kind of understand a little bit more. 5, 4, 3, 2, 1. And then on the bottom here we have 6 times, oops, not 7. Not counting up, we're counting down. 4, 3, 2, 1. And then here I have 11 minus 6, which is just 5. And 5 minus, or 5 factorial would be 5, 4, 3, 2, 1. Okay, so there's all of our numbers. Now what I see right away is on top I have 6 through 1. And on the bottom I have 6 through 1. You can cancel those off. That's what I was going to do with that little shortcut, that I could have just avoided writing 6 factorial by taking away the 6 factorial on top. A little bit of a shortcut you can take the next time. And then let's cancel some more. On top, or on, I have 5 and 10. 5 goes into both of those, making that a 2. 4 and 8 goes in there 2. 3 and 9 goes in there 3. And last one, 2, and then just cancel out with one of these 2's. So, and then I also have my variables. I have x to the 11 minus 6, which gives me 5, and whoops, and y to the 6th. Okay, cleaning this up a little bit further by just multiplying what we have left. 11 times 2 times 3 times 7 is going to give me 462, x to the 5th, y to the 6th. And that is my 7th term of the sequence. So pretty cool. Instead of doing all of that work with Pascal's triangle, you can use those factorials in that formula up above. Let's try one more. Find the 5th term. Now again, because it says the 5th term, that means that k is going to be one less, which is 4. And in this case, because we have an 8 here, n equals 8. So always write those two out first because you need those to fill in the formula. So we have 2r plus s to the 8th power equals, so plugging in my formula, 8 factorial, because I have n factorial on top, over 4 factorial times 8 minus 4 factorial times my first part of my binomial, which is 2r, raised to the 8 minus 4, and my second part of my formula, which is an s, raised to the 4th. Now again, if this was a minus sign here, we would have wanted to put a negative s with parentheses around that because that does matter as well. Okay, let's kind of expand this out. We get 8 times 4, oops, 8 times 4. I can't count down very well apparently. 7 times 6 times 5 times 4 times 3 times 2 times 1. If you'd like to take a shortcut without having to write that 4 through 1, that's fine. I'll write it out all out just because for sake of notes. 8 minus 4, this is just going to give me a 4 factorial again, so I have 4, 3, 2, 1, all repeated. Here I have 2r to the 8 minus 4. Now 8 minus 4 is just a 4, so 2 to the 4th, which is going to give me 16. And then r to the 4th, s to the 4th. So let's simplify here first. 4, 3, 2, 1, 4, 3, 2, 1. 4 cancels out with 8, making this a 2. 3 with 6, making this a 2, and then getting rid of one or more of these 2's. I'm left with 7 times 2 times 5 on top, which is going to give me 70. And then I still have this 16r to the 4th, s to the 4th on the end. Last step, I'm going to multiply these two numbers together. 70 times 16 is going to give me 1120, r to the 4th, s to the 4th. And there is my solution. And that concludes the notes for today.